Welcome back. There are some key concepts you need to understand about rigid bodies in Unity. So here I have an elevator in my game. This is the last Phoenix. Check this out. The elevator's gonna go down and land over there. But anyway, so a rigid body is basically necessary whenever you want something to have physics or be able to detect collisions. However, when you have two objects, only one of them needs a rigid body for collision detection, but any object that you want to have physics needs a rigid body. Anyway, so the elevator, we want it to have a rigid body because we want this elevator to fall. And so you just give something a gravity scale and it'll fall. By the way, check this out. This is a 2D rigid body, which also needs 2D colliders. Unity has like a 2D and 3D system. It's a little bit annoying, but in code, make sure you're using 2D or else things won't work and you'll be wondering why. Anyway, sorry, I got a little sidetracked, but some of you might know the pain of that if you've used Unity. Angular drag and linear drag, these are like frictions in the air. It's like air friction. You know, whenever you throw any object or whatever, it actually has air friction, and that's why objects reach like a terminal velocity. This is totally not information you need, but when I was in math class, a teacher told me if you throw a penny off of the Empire State Building, we did like this calculation, and she was like, yeah, and then it'll be going like 1 billion miles per hour, but it won't. That would be in a vacuum. But in the real world, even if you throw a penny off of the Empire State Building, it's not going to keep accelerating indefinitely because every object has a terminal velocity. Okay. Anyway, so angular drag is like the friction for rotation, and linear drag is kind of like the friction in the air. And then you can freeze. This right here is usually closed and most people don't notice this, but like for example, this elevator, I don't want it to tilt over and fall. So what I'm gonna do is I'm gonna freeze the Z rotation. The X rotation also stops it from moving left and right. The elevator only is gonna go up and down. That's why the Y is the only one that I don't have frozen. So even though in 2D, when I like click on an object, you can press W, that's the shortcut. And I can see there's a up and down arrow. This is for moving it, right? There's still a Z coordinate. Watch this. If I click this 2D button, boom. Isn't that cool? I love this, but you can see all the layers stacked here. But the reason why I'm showing you the Z coordinate is because now look, there's a blue arrow here and I can drag this forward and back. Obviously, if I turn 2D off, you can't tell if something's dragged forward and back because we're in 2D mode. But up here, you can see on the Z coordinate that was moved, and so you want to make sure your stuff's at 0. But anyway, what I wanted to show you is that freeze rotation, that's for the rotation. And check this out. See how if I move the Z coordinate, that's what rotates objects. When you're working in 2D, Z is the rotation of objects. That might help you out a little bit. Okay, anyway, so the thing that I wanted to teach you in this video is that the rigid body has different body types, and by default it's in dynamic, and you're gonna give things that you want to get affected by physics dynamic body types. However, there's two more here, kinematic and static. And you might be wondering, when do you use them? And I will show you when to use them. Just super quick though. When you have a collider, say this is a box collider, when you type in the word collider in Unity, a whole bunch of different colliders pop up. But anyway, when you have a collider, this is trigger. Basically, this will make it so that it's basically like an area. And then if you remove this as trigger, now it's like solid. So you see this, the green square, this is the box collider. See how it's gone? And I can affect the size of this. This is basically what the player is standing on. They're not standing on the sprite, they're standing on this invisible box collider. And if I turn this into a trigger, the player will fall right through it. So anything that's a trigger, it'll detect that something entered that trigger, that space, but it won't actually stop the player from going through it or anything. You have to make it solid for the player to smash up against stuff, or for a ball to bounce or something. You have to make sure that the trigger is not turned on. Okay, so why would we use kinematic or static? So dynamic is for physics stuff. And physics stuff like this elevator, we want it to fall. By the way, I'm gonna hit the play button, and the elevator should just start falling right away. Let's see what happens. It didn't start falling right away. Let me, oh, because it starts asleep. If I started awake, Now it'll fall. You see it? There it goes. There goes the elevator. And so start asleep basically doesn't make a physics object start doing physics until something interacts with it. And so if I do start awake, now the elevator will start doing physics right away, and it'll start going down. You see it falling? There it goes. But if I start it asleep, sorry, there's a particle effect here. I was making a particle effect for when you shatter pots in the game. Now that I started asleep, nothing's broken. The elevator will still work, but my player will have to touch it. So watch this. I'm gonna touch it, and now I woke it up, and there it goes. It's falling. So once something interacts with it, it wakes up. So why would you start something asleep? You would want to start something asleep because if it's off screen or whatever, you don't want it to be doing physics calculations. And also some stuff like that elevator right there, that's a pretty cool way to have the elevator not fall until the player reaches it, right? However, there's another way that I did it, and I'll show you why. But super quick, now you know when you would use dynamic, but I want to show you when you would use static. So let me just go back to the elevator and remind you, there's dynamic. Dynamic, you know, that sounds like something that changes, right? So that's physics. Kinematic, that sounds like I don't know if you know the word kinematic or whatever, but it kind of sounds like that doesn't describe it very well. So ignore what you know about the word kinematic. And then static means it doesn't move, right? So static is something that doesn't move. It's a static object, and static is when you still want it to be that hard surface, but you don't want it to have physics. So remember, the player landed on it, but it fell. It fell because it had physics, but the ground's not falling, right? And so if I go here to my ground, this entire ground, you can see it has this green stuff is basically the collider that's created for this tile map. But if we go to the tile map's rigid body, you can see it's set to static. It's not set to dynamic, because if I set it to dynamic, it would fall. You guys actually want to see that? Watch this. If I hit play, I think the whole level will fall now. Yeah. Oh my God. Oh my God, the level fell, dude. So there's a perfect use of static right there. If you want things to go through each other, that's when you create triggers. And I created a trigger for this elevator, and I'll show you exactly how the trigger works super quick for that elevator. But I wanted to show you why I created that trigger. I didn't want the elevator to fall until the player interacts with it. However, an enemy could interact with it, and then it would still fall. So I have this spiked snail enemy, and I'm just gonna put it here, and I'll show you what I mean. So I thought about setting the elevator asleep, and then just you know, when the player runs up to it, the elevator will fall. However, let's do that right now. I'm gonna go to the rigid body of the elevator, and we're going to start it asleep so it will not fall. But I think that when the snail touches it, the snail's gonna activate its rigid body, and the elevator is gonna fall. So here we have the snail, it touched it, and the elevator goes down. And I don't want that to happen. I want it to be the player that gets the elevator to go down. And now I could code the elevator going down in code, but that's dumb. I still want it to have physics, but I only want it to have physics when the player shows up. So I'm going to not start it asleep, I'm gonna start it awake. And remember, if I started awake, the elevator is just gonna fall straight down. So what the solution here is to start it as kinematic. And now if I start in kinematic and I start it as awake, and I have the snail there, what will happen is, take a guess. We got the collision going, but the physics isn't going. And so all I need to do now, this is the last step, right? The last step to this thing, is I created a trigger on the elevator. So I'm gonna click the elevator. Here's the elevator. And then let me remove the spikes now real quick. So I'm gonna go back to the trigger that I created. And remember that the trigger is just a box collider, but the is trigger box is checked off. And when I turn this on, you can see that there's a little square here, right above it. And now if I turn this is trigger off, if I jump on this elevator, you can see my character's standing on it. He hasn't landed because he's standing on this trigger box. And look, if I make the trigger box taller or move it, you can see my player. If I go to the scene view, you can, oh my god, the gizmos. Come on, the trigger, this is the trigger right here. You can see that the player's standing on it, and so the player doesn't go through it. But if I turn it into a trigger, then the player will fall through it. Here I have an on trigger enter, and don't forget the 2D. If you're working in 2D, don't forget this needs to be 2D and this collider needs to be 2D. But basically I have on trigger enter 2D here, and that's when I invoke a Unity event. You see how I did a public Unity event and I just called it an event, and then over here I invoke it. The question mark just checks whether it's null or not. I know this isn't about programming, but the reason why I did that super quick is that's how you make this. And the cool thing about having a public Unity event is that you can create, you can drag any object here and call any script here. And this is like visual programming. So basically you can link stuff up visually instead of always hard coding it in the code. And I really like this system. So basically what I did here is I have the gears start spinning, but this is what's important. I take the elevator rigid body, and here you can set what the rigid body is, whether it's kinematic or not. So just once again, I'll show you. Here we have the trigger, and I took what I needed to do is I needed it to go to the elevator. And I needed to go to the rigid body 2D, and the elevator has a rigid, these are all the components that are on that game object. So there's a rigid body 2D there. And now I want to turn the physics on. And remember that when it's kinematic, it's not going to use gravity. And so, where's the kinematic thing? Is kinematic, there we go. And then this is just a true or false checkbox. So if it's true, it's going to be kinematic. If it's false, it's not. And so the object, the elevator starts kinematic. You can click this little lock button in the top here. And now if I click a different game object, it won't go to it. So you can see that the body type is kinematic, but once I reach that trigger, I'm gonna change the body to dynamic, and then the elevator will fall. Check it out. It turned to dynamic, and now the elevator falls, and boom, we hit the bottom, and we're in our boss battle room. Amazing. So basically, static is for game objects that don't move and you want them to be solid, and the box collider for those objects does not have the trigger checked off. But for objects that the player that use physics, you want dynamic. But for objects that still you want to have collisions with, but they can move, like for example, you could have a moving platform that moves back and forth. You don't want that to be dynamic, or else physics could move it around. But if you have a platform that moves back and forth, you don't want that to be static either, because static is for objects that don't move. So platform that moves back and forth, but does not fall or cannot get pushed by physics, but it moves back and forth, that's the perfect time to use kinematic. Moving platforms. And when you're moving the platform with code though, this elevator, I'm letting physics move this elevator. That's why I'm keeping it dynamic. I could have moved it through code, and if I did, I would have left it as kinematic the whole time. I like adding physics into my games. Even the movement has a little bit of physics in it because it adds a lot of fun interactivity. Now that you know a little bit more about how rigid bodies work and colliders, let me show you this pot here that I have. So I have this pot right here. For fun, I'm gonna duplicate it and put a couple of them here. And basically, I'll just show you. The pot, it randomly changes its sprite. That's why they have random heights. It just happened to be a coincidence that they gradually get bigger. But the pot, if I touch it with my body, it breaks it. You see that? It's shattered. Or if I shoot it with the fireball, oh my god, the fireball came out sideways. You guys see that? Yeah. I'll fix that later. So now that you know a little bit more about colliders, geez man, always like 2 steps forward, 1 step back with this stuff. If I go to one of these pots, oh, let me unlock it. Disregard that. You can see that it's dynamic. And you might be wondering why I made it dynamic. I made it dynamic so that if it's on a floor that you destroy, it falls. So basically the pot can be knocked over, pushed around, whatever. It can fall, and when it falls, it'll break. Actually, let me show you. I'll if I put this pot in the sky here and hit play, you should see it fall right in front of me, and I think it'll shatter. Let's see. It might not shatter. It didn't shatter, but you did see it fall, right? Actually, the cool thing about Unity is right in the, oh, I just shot them all. Right in the game engine, I can lift it up and we can watch it. And you see that? It falls. So I did that because I have destructible floors. So like, check this out. If I destroy this floor, now the pot fell down. So that's why I added that's why to the pots I added a rigid body, because I wanted it to have physics. It's unnecessary. Like, some of that stuff is unnecessary, right? You could just have the pot shatter automatically, but I think people's computers are, can handle my game. Switch 2's coming out, so I think it'll be able to handle it. But as you can see, that I don't have a trigger on it. It's I'm using a collider for it, but I have two colliders. And if I go into the pot, I have the one where the rigid body is. That one is solid, but then I created a separate game object called trigger. This one is checked off, and it's the trigger is this right here, and this is what's waiting for and detecting if the player or your fireball touches it. So basically, very often you want to have one collider that does not have is trigger checked off. This one is for physics. That's this little one. You see that? That's for physics. And then another collider that does have the is triggered checked off. And this one is going to be just checking what it collides with, and or what triggers it. And that's how I build a lot of stuff in Unity when I'm using physics. I don't like to use on collision enter. As you saw in my code, I prefer to use on trigger enter. The difference is that on trigger enter gets triggered if you have that checkbox checked off. On collision enter gets triggered with colliders, not with triggers. And remember, they're considered, they're both colliders. A trigger is a collider, but if someone says, oh, it's a collider, they usually mean that it's not checked off. I think. I'm not sure. I'm an indie dev and I work by myself, so. There's a link in the description to my Kickstarter. I'm gonna launch the Kickstarter in a few months. So I hope you're a backer. And all the core stuff is kind of done, like the shop, the town, the map, the skill tree. So there's gonna be a demo coming pretty soon. I'll see you next week. A Dev Life.